Mars, cold, dusty, and silent today, hints at a very different past. Evidence suggests it once hosted conditions friendlier to life. At first glance, it seems barren, yet across its surface are traces of ancient rivers and lakes carved into the rock. Appearances can mislead. Long ago, Mars likely had a thicker atmosphere, a warmer climate, and liquid water flowing across its plains and craters. Let's start with the air. Early Mars likely kept heat better, with an atmosphere dense enough for stable surface water. Channels branch like tree roots, merging into wider valleys, classic signs of rainfall and runoff feeding lakes and basins. Sunlight, clouds, and a thicker blanket of air would have supported rivers over long periods. Layered rocks preserve that story, each band a page from an ancient lakebed. Picture water cutting through soft sediments, leaving meanders and tributaries, geology that mirrors dry river systems on Earth. At the ends of these networks, we find deltas, fan-shaped deposits where rivers slowed and spread into standing water, like the one in Jezero crater. Layered outcrops show fine sediments laid down in calm waters. Crossbeds and ripples point to gentle currents and shifting shorelines. Minerals add chemistry to the picture. Clays, formed when water alters rock, are common in ancient terrains. We also see sulfates and carbonates, hints of neutral to mildly alkaline waters where life's chemistry could have been possible. In astrobiology, habitability means liquid water, energy sources, and essential elements. Mars once checked those boxes in several places. Rovers brought this story into focus. Spirit and Opportunity traversed ancient plains, reading the planet's watery past in stone. Opportunity found hematite, blueberries, tiny spheres formed in water, ground truth for mineral evidence from orbit. Curiosity drilled mudstones in Gale Crater, revealing an ancient lake environment and organics preserved in fine-grained sediments. It also saw seasonal changes in methane, an intriguing signal with many possible sources, geological or biological. Today, Perseverance explores the Jezero Delta, caching samples that could reveal whether ancient microbes ever left a trace. Clues in the air tell another tale. Isotope ratios show Mars lost much of its atmosphere over time, thinning the blanket that once kept it warm. As the planet's interior cooled, its global magnetic field likely faded, removing a shield that once helped protect the air from the sun. Solar wind then stripped gases away. With less greenhouse effect, Mars cooled, surface water vanished, and the world froze and dried. Today's surface is harsh. Thin air, cold temperatures, dust, and radiation. But below ground, ice and ancient rocks preserve the planet's memory. Orbiters map buried glaciers and mid-latitude ice, suggesting reservoirs that could archive past climates and chemistry. Salts may allow thin brines to form in special places, though the recurring slope lineae remain under debate. The big picture. Mars transitioned from potentially habitable to forbidding as its shield weakened and its air thinned, a planetary turning point. Hydrothermal systems, volcanic heat, and groundwater once provided energy and chemistry, niches where microbes might have endured. But habitable does not mean inhabited. That's why missions like Perseverance and the planned sample return are so important. Each core and cache will help test for biosignatures, patterns in chemistry and texture that life can imprint in rocks. In the end, Mars is a world of contrasts. Beautiful from orbit, rust-red and bright, yet up close a severe desert that still holds gentle memories of water. Its valley networks, deltas, lake beds, minerals, and layered rocks make a compelling case that it could have supported life long ago. As we explore, Mars reminds us how quickly worlds can change. It's a cautionary tale, and a laboratory for understanding climates and the origins of habitability. So when you spot that red point in the night sky, remember, within those rocks may lie a record of a friendlier Mars and a clue to life's possibilities.